Hello and good evening to all of you. So today we'll try to complete space science and technology. So we had left this portion. So we'll try to cover this portion today. So in space science and technology, we had started with the various launch vehicles, and we had seen how does a rocket engine work. So we had seen the working of PSLV, we had seen the working of GSLV, and we said that we have also developed SSLV and RLVTD. So we'll try to cover SSLV and RLVTD also today. But let us just try to understand the different missions that are sent using these launch vehicles. So today we'll be focusing on the different missions that different space agencies they send to different planets or to sun or to asteroids, meteors. So we'll try to study those aspects today. So today we'll be focusing mainly on the missions. So before we understand missions, there are some concepts that we need to understand. So the concepts like what is an orbit? So we need to have some clarity with respect to the orbits that we use. What is orbit? And you would have heard that we use different types of orbits. So you would have heard that there is something called as low earth orbit, there is something called as geosynchronous orbit, GSO. One subset of GSO is your geostationary. So geostationary, so you have geostationary also. So telecommunication satellites we send to this type, geostationary. So the geostationary is one set of your GSO. Then you have what are called as medium earth orbit. So what are these? We will try to develop an understanding of this. Then you would have heard about polar orbits, and you would have also heard about something called as sun synchronous orbit. So we'll try to develop an understanding as to how the sun synchronous orbit is different from your geosynchronous orbit. So this clarity, it should be there. Why? Because I'll show you a question. UPSC asks question based on your understanding of this. So you need to have clarity with respect to these type of orbits. So sun synchronous. So what is the sun synchronous? And one of the concepts that is called as the GTO or the geo transfer orbit. So what is this transfer orbit? We'll try to understand. And a related concept is the concept of Lagrange points. So often there is some confusion with respect to Lagrange point. So we'll try to take those doubts also today. So first of all, we'll develop the understanding of the orbits and the Lagrange points, and then we'll cover the missions. So what we have done with respect to missions is that we are not just looking at some of the random missions which were sent very recently. What we'll do is that we'll look at missions to sun, then we'll look at missions to from the start of the planet, that is from Mercury, Venus, Earth's moon, then to Mars, Jupiter, Saturn, Uranus, Neptune, and then outwards. So there are different space agencies they have sent different missions to these planets and to sun. So we'll try to develop a holistic understanding, and we'll try to see some of the past missions. So the past missions you should know just for a reference, but we'll focus mainly on the current ones. But in this way we'll try to develop a holistic understanding of the missions and not just some random preparation of missions. Before we begin with missions, let us just try to understand orbits. But I'll show you one question that was asked. So what is the significance of this topic of missions from prelims point of view? Let us just try to understand and go at it through this question. So let us try to solve this question. Yes, online students, you can give it a try. Cassini-Huygens orbiting the Venus and transmitting data to the Earth. So was Cassini mission sent to Venus transmit, and it is transmitting data to Earth. So it is a very simple question that whether Cassini mission was sent to Venus or not. So if you know that, if you have a holistic idea of the different missions, Cassini was not sent to Venus. Cassini was sent to Saturn. It was sent to Saturn. So this statement is not correct. So Cassini was not sent to Venus. So if you can eliminate that just by using first option, you can see that you can reach to the answer. Messenger was obviously yes, it was sent to Mercury. One of the earliest missions to Mercury was before Messenger also. There were some other missions also that we'll try to see. Then you have the Voyager. We are trying to explore the outer solar system, so we have Voyager 1 and we have Voyager 2. So we'll try to understand what are these Voyager, what is their role. So another question which was asked related to missions is this: the experiment will employ a tree of spacecraft flying in formation in the shape of an equilateral triangle that has sides 1 million kilometers long, with lasers shining between the craft. The experiment in question refers to. Yes, would anybody like to try? What would be the answer to this question? What would be the answer to this question? I guess there is some technical issue. Is my screen visible to all of you? Hello? I guess. I guess. Hello? Hello? Uh, is my this screen? I have shared a PPT file. Is that visible to all of you? Hello, Ram. Is my screen visible to all of you? A space technology screen. So there is some issue here. Hello, hello. Am I audible? Is my screen visible to all of you? Hello. Hello, is my screen visible to all of you? I guess the my screen is not visible to all of you. Uh, just trying to fix the issue. हेलो. हाँ आशीष बताइए. हम्म. पीपीटी ऑन है मेरा, मैंने पीपीटी खोल रखा है पर वो दिख वो. हम्म. अब दिख रहा है. हम्म. ग्रीन कलर की स्क्रीन है. वो मैंने फुल स्क्रीन कर रखा है पीपीटी. हम्म. ओके. So there is some technical issue. I'm not able to show my PPT. So the team is working. So hello and welcome back. So there was some technical issue. So we have resolved the issue, and I hope this screen is now available to you also. Yes. So it is visible to everybody now. So what we'll try to cover today is the different missions to different planets and to a sun. So before that, we'll see the different types of orbits. So we'll try to understand what are orbits. So what is an orbit? Orbit, before we begin with the orbit, what is the importance of this topic, of what is the importance of this topic of missions? So missions is very important from prelims point of view. Specifically, you can see in this question, so they ask questions related to missions, so you need to have a holistic understanding. So in missions, what we'll be doing, will not be just studying, let us say, random missions, but what we'll do, we'll try to study it in a more organized manner, and we'll try to cover the past mission also and the present missions also. So mainly we'll focus on the present missions, but we'll have an idea of the past missions also. So we'll cover in a systematic manner. We'll look at missions to sun, then missions to Mercury, Venus, Earth, Earth's moon, Mars, then Jupiter, Saturn, Uranus, Neptune, and in between we'll see missions to asteroid also. So we'll cover the some of the recent missions also and some of the past missions also. So you will be able to answer questions like this. So everybody, please try this question. Please try this question. So you take this as, and this as 1. So this is 1, this is 2, and this one is 3. Okay, so let us just try to solve this question. So, how will we be able to answer such type of questions? Only if we know the missions in a holistic manner. So, we'll try to cover all these missions. Cassini-Huygens was not a mission to Venus. Cassini-Huygens mission was sent to Saturn. So, if you knew just this fact that Cassini-Huygens was not sent to Venus, you could have got to this answer. So, if you eliminate one, so you are getting that only option B, that is 2 and 3, is correct. So messenger was sent to Mercury. Voyager has been sent to the outer solar system, so it has crossed what is known as the heliopause, so it is trying to move out of the solar system itself. So these questions you will be able to answer if you have a holistic understanding. Now let us just look at this question also. The experiment will employ a trio of spacecraft flying in formation in the shape of an equilateral triangle that has sides 1 million kilometers long, with lasers shining between the craft. The experiment in question refers to. The experiment in question refers to. So this the answer to this question is this one. So evolved Lisa. So evolved Lisa is a yes. So evolved Lisa. So LIGO is quite a news. So you need to know what is LIGO, what is evolved Lisa, what is this Lisa Pathfinder. So we'll try to develop an understanding of this also. So today on my channel also I've shared that Indian LIGO. So we are talking about LIGO India. So India has also come up with a plan that it will set up LIGO in India in Maharashtra in Hingoli district. So this is in news. So we'll try to understand what is this LIGO and what is this evolved Lisa. So they all are related to the concept of gravitational waves. So we'll try to develop an understanding of what are the gravitational waves, and we'll also try to see how we can measure these gravitational waves. So let us just quickly look or refresh our knowledge of orbit. So what is an orbit? Orbit is a curved path. So what is an orbit? Orbit is a curved path. So our our sun is also following an orbit around the center of a black hole of our Milky Way galaxy. Similarly, our Earth is revolving around sun. So moon is revolving around Earth in a curved path. So these curved paths are what are known as orbits. And why these objects orbit another object? It is because of force of gravity. So because of force of gravity, these paths are orbiting each other. So that is what is orbit. That is the general sense of orbit. Now we need to understand the different types of orbits. So we in the start of the class we had said that there are mainly 6 type of orbits. These orbits have been mentioned by your European Space Agency. So European Space Agency says that there are 6 main types of orbits. So there are low Earth orbit. So this one is known as LEO. Then you have geostationary orbit. So it is part of the geosynchronous orbit. So one of the geosynchronous orbit is your geostationary orbit. Then we have the medium Earth orbit, and then we have polar orbit, sun synchronous orbit, transfer orbit. So let us just quickly look at these types of orbits, then we'll look at the different missions. So one of the key characteristics of low Earth orbit, that you should remember that the altitude should be less than 1000 kilometer, and it should be above 160 kilometer. So it should be more than 160 kilometer but less than 1000 kilometer. So we call it as low Earth orbit. And what is the uniqueness? That the satellites in this orbit do not have to follow a particular path, so they can change the path. So it means that they need not follow the same path every time, so they can change the path. So they can change the plane every time. So this is the uniqueness about low Earth orbit. And low earth orbit is commonly used as an orbit for satellite imaging, as being near surface allows it to take images of higher resolution. The best example of your low earth orbit is the International Space Station. And also, when we talk about Gaganyaan mission, what is this Gaganyaan mission? In Gaganyaan mission also we'll be sending what Indian astronauts. So we'll be sending three astronauts, one among which will be a woman also, and they will be sent to which orbit? They will be sent to low earth orbit only. So they will stay there for 5 to 7 days, and then they will be brought back safely to earth. So low earth orbit is the most significant orbit. And if you look at the other orbits, low earth orbit, and if you look at geosynchronous orbit, so they are high altitude orbits. So in order to maintain its position in the low earth orbit, object has to move very rapidly in these orbits. So, and in this international space station makes 16 rounds per day. 16 rounds per day. So it makes one circle of the earth in just about 90 minutes. So if an object has to remain in low earth orbit, it has to move at a very fast pace. That is the uniqueness of low earth orbit. Next type. So this is just an example to show you, image to show you. So here you can see that we are saying that the altitude. So when we say altitude, this is from the surface of the earth, that it should be less than 1,000 km. When we talk about space, we say that there is what is called as Karman line. So Karman line, the accepted value of the Karman line is around 100 kilometers. So we say that beyond 100 kilometers the space starts, and we are saying that in between 160 to 1000 we are calling it as what? As Leo. We are calling it as Leo. So that is the idea of Leo. So what is this geostationary orbits? Geostationary orbits are your high altitude orbits. So these are high altitude orbits. It means it has an orbit of around 36,000 kilometers. So you can just remember a round figure. So the altitude of geostationary orbit is 36,000 kilometers. So why it is called as geostationary? So it is a subcomponent or a part of your geosynchronous. So what is geosynchronous? It means that the satellite in this orbit is in sync with the rotation of earth. It is in sync with earth. That is why it is called as geosynchronous. One special case of your geosynchronous is your geostationary orbit. So here you can see that this is a geostationary orbit which is up in the plane of the equator, or which is above the equator. So above equator you can see this distance of around 35,000, so around 36,000 kilometers. So this orbit is known as a geostationary orbit. So if you place any object in this geostationary orbit, it appears to be stationary with respect to earth. Why it appears to be stationary with respect to earth? Because its revolution speed is same as the rotation speed of earth. So if earth is making a rotation in 24 hours, the satellites in this orbit will make one revolution in 24 hours. So that is why it appears to be at a particular position only. So in at your homes you would have seen that your these antennas, so your TV antennas or the dish TV antennas, they point towards a particular point in the sky only. Why do they point towards a particular point in the sky only? It means they are seeing something. It is sending data to some satellite and it is receiving data from that satellite. So it is appearing fixed to that antenna, so your TV antenna. So telecommunication satellites are placed in your geostationary orbit. That is the uniqueness of geostationary orbit. And obviously when we are saying that this is a high altitude orbit, it means its speed is much less than compared to your low earth orbit. So in low earth orbit you had seen that International Space Station cuts the earth or makes 16 revolutions around the earth. Here you are seeing that it is making only one revolution around the earth in one day. So the speed is less in high earth orbit. So this you should take a note. The closer you get to earth, the more speed you need to have to escape the gravity of earth. the further you move away from Earth, the slower you will get. So you are not facing that problem. Why? Because the centripetal force reduces. So in stationary Earth, the uniqueness about this is that we are matching with the speed or rotation speed of Earth. So telecommunication satellites, most of the telecommunication satellites are placed in your geostationary Earth. So as an example, you can remember that if a satellite appears above Delhi, then it will always appear above Delhi if it is placed in your geostationary orbit. So that is the uniqueness that you should remember. We'll use this example again when we see sun synchronous orbit. So in sun synchronous orbit, so there is a uniqueness. So we'll try to compare this example again when we see the sun synchronous orbit. So what is medium earth orbit? Then medium earth orbit is any orbit which is in between your high earth orbit and low earth orbit. So high earth orbit altitude is 36,000 kilometer, and the higher range of your low earth orbit is 1000 kilometer. So anything in between 1000 and 36,000 kilometer is referred to as your medium earth orbit. So you'll see that most of the satellites which are used in your navigation systems are being sent to medium earth orbit. So the best example is the European Galileo. So most of its satellite is in most of it every satellite of it is in your medium earth orbit only. In GPS also, most the satellites are in MEO only. So this is an example which shows that. So Galileo constellation, Galileo is what a navigation system of Europe. So it is a regional navigation system and its satellites are in MEO, polar orbit. So let us now just try to understand this polar orbit. So polar orbits are a form of your low earth orbit only. So here you can see that it is 600 to 800 kilometer. So it moves above the poles only. So it appears that it is not moving in west to east direction, but it appears that it is moving in north to south direction. So that is why it is called as polar orbit. So it is a form of your polar orbit only. Now another form of polar orbit is your sun synchronous orbit. So here we are saying sun synchronous. So how is sun synchronous different from geosynchronous? Sun synchronous versus geosynchronous. Yes, can anybody tell what is the difference between sun synchronous and geosynchronous? What is the uniqueness about any satellite which is placed in your sun synchronous orbit? Okay, so nobody is taking a lead. So let me just explain what is this sun synchronous. Sun synchronous means it is in sync with sun. So when can you say that the satellite is obviously revolving around Earth only, but how is it in sync with sun? So it is in sync with the time. So what we are saying that when we say day and night is what the location, the local time. The local time is in sync with sun. So here, if you take that example of a satellite which is above Delhi. So if you place a satellite which is above Delhi in geostationary, so it will always appear to be above Delhi. But if you place a satellite which is in sun synchronous, then let us say if it appears above Delhi at 8 a.m. in the morning, then it will always appear at 8 a.m. in the morning only and at no other time. So it is in sync with the local time. So you just remember that when you say sun synchronous, it means that it is in sync with local time. So if it appears above Delhi at 8 a.m., then it will always appear at 8 a.m. only. At 8 a.m. only. So what is happening here? It is not that the satellite is making one round only in 24 hours. It is making multiple rounds. It is making multiple rounds, but the earth is also rotating. So it matches in such a way that when the next time when the satellite comes over Delhi, the timing matches, or it comes over at 8 a.m. only. So that is the uniqueness about sun synchronous orbit. So it is a form of a polar orbit only. It moves north and south. It appears to move in north south direction, and it has a high altitude in your low earth orbit only. So here you can see that the altitude is around 600 to 800 kilometers. So that is the uniqueness about your sun synchronous orbit. Let us just try to understand the transfer orbit. So what is a transfer orbit? So transfer orbit is a orbit which is used to move from one lower orbit to a higher orbit. So if you see, this is our earth, and let us say from earth we want to reach to this part. We want to reach to this orbit, which is a geostationary orbit, but we do not have the sufficient fuel. So what do we do? So we launch from earth. We enter into an elliptical orbit. We have entered into an elliptical orbit. We'll reach to this point. And we'll fire the engine. And now instead of moving in this one, it will start moving in this orbit. So what are we doing here? So this elliptical orbit, this blue color elliptical orbit that you're seeing is a transfer orbit. So it is being used to shift from a lower orbit to a higher orbit. So this is what we utilize when we have to move from a lower orbit to a higher orbit. So India utilized this in your Mangalyaan mission. So we used GTOs or transfer orbits to reach Mars. So what have we done actually? So we have matched, what is this length called as? In an ellipse, this longer length is called as apogee. This longer length is called as apogee, and this short length is called as perigee. So what we have done is that we have matched this length and this length. So this length is equal to this length. This length is the radius of the larger orbit, and this is the apogee of the elliptical orbit. So when it reaches at this point, when it is at the circumference of this, we fire the engines and it starts moving now in this one. So this is the idea of the geo transfer orbit. Is it clear? Okay, so now let us just try to understand these Lagrange points also. So you need to have some conceptual clarity with respect to the Lagrangian points also. So what is this Lagrange point? So let us just try to understand. This is your sun. So this is sun, and this is earth. So when we say Lagrange point, if we place something, let us say an object closer to sun at this point. If we place an object closer to sun from earth, closer means with respect to earth, so this will have more speed than earth. So it will move faster around sun than earth. It will move faster around sun than earth. And if you take some object here, it will move slower than earth. So what we are saying, that there are some points in space. So if you talk about this L1 point, here the gravitational pull of sun and earth, they combine in such a manner that it will move around sun in, let us say, just 365 days only. Otherwise it could have moved around the sun in less than 365 days, but because it is placed at this point where gravitational forces of sun and earth act in such a manner that it gets linked with earth's movement, or it gets anchored with respect to earth. So if earth is revolving around sun in 365 days, then this point also will move around sun in 365 days and not faster. So that is the uniqueness about this L1 point. Similarly, you have this L2 point also. L2 point should have been slower than Earth. It should have taken more than 365 days. Any object, if you place at this point, let us say at this point or at this point, it should take more than 365 days. But if you place at L2, it will take just 365 days only to move around sun. So what is happening? It appears that this point is anchored with Earth. This point, the L1 point, L1 point, L2 point, L3 point, these appear that they are anchored with respect to a Earth. So the advantage is that we need to spend less fuel when we are placing some objects at L1 and L2. And if we place something here at L1, so can you see that it gets a good visibility of sun? So it is free from solar eclipses also. So that is the biggest advantage of placing something at L1. So you would have seen so there are some missions like the Soho mission. We have placed it here. We are placing Aditya mission at L1 only. Aditya. So why the name L1? Because we are sending it to the L1 point. We have also sent here Lisa Pathfinder. So Lisa is a space-based antenna for observing gravitational waves. So Lisa is also placed at L1. At L2, what is the significance of L2? At L2, we have placed the most famous telescope, that is your James Webb telescope, and there is a European mission that is called as the Gaia mission. So we have placed at L2 your James Webb telescope and the Gaia mission. Is the L2 point clear? So what are these points? So these points L1, L2 and L3 lie in the line joining sun and earth. So L1 is between sun and earth, L2 is behind earth, L3 is behind the sun. L4 lies at an apex of the equilateral triangle formed by joining sun and earth as base. So all these sides are equal. So you'll see that this point is L4 point, and these points are called as, this one is called as L5 point. So there are 5 such points. So we know the utility of L1 and L2 and L4 and L5 also, but L3 point has not been quite used by scientists because it always remains hidden behind the sun. So communicating with this point becomes difficult. So we have not been able to find any usage of this point as of now. So Lagrange point, you should have some clarity that what is the uniqueness about these Lagrange points, that the gravitational forces they combine in such a manner that any object placed at these Lagrange points they appear to be anchored with respect to Earth, and that is the advantage. So it takes less fuel to remain there, and there are some advantages with respect to the specific point. So this is the idea of the Lagrange points. So this is the structure of solar system. So when we talk about missions, so let us now get to missions. So when we talk about missions, there are 4 types of missions. The first type of mission is the flyby. These are the simplest type of mission. Then the second type of mission is your orbiter type of mission. Then the third type of mission is, obviously it is orbiter, but it also has lander and rover. And then fourth type of mission is what is called as the manned mission. So flyby mission are the simplest type of mission. So they are the simplest type of mission. So if you talk about flyby, it means the satellite or the space exploration vehicle, it flies past a particular celestial body and takes some photographs. So we study those photographs to study the surface or the atmosphere. So that is the idea of the flyby mission. So flyby missions are the simplest among all types of missions. So even if you talk about recently this Parker mission, so the Parker mission was sent to sun. But it flew past what Mercury and Venus. It flew past Mercury and Venus, and we were able to take photographs of Mercury and Venus. So with respect to Mercury and Venus, Parker mission is a flyby mission. Next is your orbiter type of mission. Orbiter type is a more complex type of mission. So here we are entering into the orbit of any celestial body. So that is the idea. So we are entering into the gravitational field of that particular celestial body. So all the missions, most of the missions we are sending is orbiter type only. So if you talk about Chandrayaan, if you talk about Mangalyaan, if you talk about Artemis mission, so they all will be orbiter only. Artemis mission is a special mission which will see as a manned mission. Then you have a more sophisticated type of mission, which is the lander and the rover. So you would have heard about Perseverance. Perseverance. So Perseverance is what type of mission? It is a lander and a rover type of mission. It has been sent to Mars. So these are more complicated mission. So it is not only about moving around the orbit, but also from the orbit we are landing onto the surface of the celestial body. So it makes the process much more complicated and sophisticated. And we are not just landing. In cases of rover, we are also sending a robot which can move on the surface of the planet or asteroid, and it can take or collect some samples. So this is the lander or the rover. Next type of mission is the manned mission. Manned mission is the most sophisticated type of mission. So not many manned missions have been sent. The first manned mission was the mission which was sent by Russia. That was the mission of Yuri Gagarin. So Yuri Gagarin went into space and then came back on Earth. So it was the first manned mission, and later USA started the different manned mission, and the then president of USA was John F. Kennedy. So he challenged the scientists of NASA to send humans not only to space but to moon. So within 10 years of time, so NASA was able to send humans to moon. So the famous Apollo 11 mission was sent in 1969. The Apollo mission started in 1968. It continued till 1972. So 12 astronauts have walked on surface of moon, and after that, so there was lull, or there was stop. These manned missions stopped. So the new manned missions, the Artemis mission is starting. So with respect to manned mission, this is the most important type of mission that you should be knowing. So you should, this is in news. So Artemis mission is in news, and your Gaganyaan mission is in news. So we should be aware about these type of missions: Artemis mission, Gaganyaan mission. So we'll try to develop an understanding of these type of missions. So let us first look at missions to Sun. Missions to Sun. In missions to Sun, let us just quickly look through the important missions. So the most important mission is this mission, the Parker mission. The Parker mission is the most important mission that you should be knowing. So it was in news. Why? Because there is a claim that it has touched Sun's corona. So it has touched Sun's corona. So can anything touch Sun's corona? It has touched Sun's corona. So can anything touch Sun's corona? So that is the question that we'll try to answer. So there were earlier missions like Iris, MMS, Soho. So not very important from exam point of view, but this Soho you will see. MMS also will see in briefly. And these are some of the older missions. Older mission, ACE and High Note, Stereo. These are old missions to Sun. And India's mission is Aditya mission. So earlier it was just called as Aditya, but now we have added a suffix, that is Aditya L1 mission. So it will be sent to the L1, Lagrange point L1. So let us just look at this Parker mission. So Parker mission, so the unique design of the Parker is that it has this shield. It has this shield. It has this shield. So you can see this shield. So this shield provides protection against the charged particles coming from the sun. So here you can see that the shield is made up of very unique material. The materials are not very important for you to know, but all the instruments that you're seeing, it is placed behind this shield only. So this Parker mission reached Sun, and it has touched Sun's corona. So yes, it is possible to touch Sun's corona. Corona is hotter than the previous layers such as the photosphere, but it is the least dense part of Sun. So we have designed this Parker mission in such a way that it can bear or it can withstand for some time these charged particles or these particles in the corona. So it touched sun's corona, and then it moved out. So for a brief period it touched sun's corona. That is the uniqueness, that is the unique achievement about this Parker mission, that can anything touch sun's corona. So yes, it touched sun's corona. Parker mission has been named after Eugene Parker. So Eugene Parker was the one who who first theorized the concept of solar winds. So solar winds. So this question had come last year. So what is solar winds? What is solar flares? So what are solar winds? Solar winds are charged particles that keep coming out from sun's surface. So they have a kind of a constant speed, but there are some incidences, there are some other incidences also where the charged particles emerge at a very rapid pace. So they are sporadic in nature. So those are called as solar flares. So then there are what are known as coronal mass ejections. Those coronal mass ejections are so charged particles which is coming from the corona. So they are called as a coronal mass ejection. So Eugene Parker was the one who theorized the concept of solar winds way back in 1950s. And this idea of solar wind is very important for us to understand. Why? Because these solar winds determine the space weather of the entire solar system. So the our solar system's space weather is determined by solar wind. So last year you would have heard that Elon Musk Starship program. So in his Starship program, there are many satellites which will provide internet through satellite, and many of these satellites, more than 40 of these satellites, were damaged because of solar flares. These solar flares are nothing but charged particles which come from sun. They are sometimes sporadic, but what we see that they maximize during a particular period. So there is something called as solar cycles. This solar cycle corresponds to what is called as the solar solar maximum, or the sun. Just like our earth has a magnetic field, similarly sun also has magnetic field, and its magnetic field fluctuates, or it switches, it flips in every 11 years. So because it flips in every 11 years, what do we mean by flipping? It means that in every 11 years, so the north pole becomes the south pole. So what we see is that there is some solar maximum minimum. So so there is some peak period. So it starts and in 111 year it will complete. So there is a maximum period. So during these periods you see maximum intensity of solar flares or coronal mass ejections. So because of that only, so these solar flares destroyed the satellites of Elon Musk Starlink program. So these solar flares can destroy satellites, can destroy other type of satellites. It can damage the International Space Station, some of the equipments of the International Space Station. It can damage or it can be harmful to astronauts also if they are in International Space Station. It can damage your navigation system, that is like a navigation system like the GPS or the GLONASS or your Navig. It can damage that. It can damage even the power grids also. So this is the potential of the solar mission. But most of these charged particles, they are prevented. So in this diagram you can see that this is sun. So this the outer mass, the outer part that you are seeing is this part is the corona part. So this part is the corona part. These are called as coronal loops. These are called as coronal loops. So these charged particles, they emerge, and they emerge from the surface. These coronal loops are the loops of the magnetic fields also. So in the earlier missions are not very important, but one mission that you should understand, in this mission we are trying to understand the magnetic field of sun and earth. So this is earth, and what you are seeing, these lines are the magnetic fields of earth, magnetic field lines of earth. This magnetic field line, you can see that there is a shield that is created. So there is a shield that is created here. So the charged particles which are coming from sun, so these are solar winds. These solar winds, they are deflected away. They are deflected away because of this shield. But some of the charged particles, these charged particles, they are able to reach to the north pole and the south pole. So these charged particles, because they reach the north pole and the south pole, they create what are known as auroras. So auroras are caused because of what? Because of the charged particles coming from the sun, and they are able to enter the north pole and the south pole of earth, and they interact with the gases of the atmosphere, and they produce colored lights, which are known as auroras. The Soho mission is an old mission. You just need to know that it was sent in 1995, but and it was supposed to end in 1998 itself, but it has continued for very long until 2025. It has given approval to operate. So this Aditya L1 mission. So Aditya L1 mission, it will be India's first mission to your sun. And here we'll be sending it to L1 point. Why are we sending it to L1 point? Because it can observe the sun. It will get a clear picture of the sun without any eclipses. And because it is at L1, we'll need to spend less fuel to stay at L1. And what will be the launch vehicle? So we'll be using your polar satellite launch vehicle. The objective is to study sun's corona, sun's corona, sun's photosphere, sun's chromosphere. So these are the outer layers of sun. So these are the outer layers of sun. And it will also study solar winds, solar flares, coronal mass ejections, and it will carry out the imaging of around the clock imaging of the sun. So this is a planned mission uh, to sun of India. So Aditya mission, you should take a note. And then let us see missions to Mercury. So missions to Mercury, one of the mission to Mercury is your messenger. So it was sent in 2004. It reached in 2006. So you can see that it takes around 6 years to reach Mercury. So it is quite far from Earth, and then it was deliberately brought down to the planet's surface. With respect to Mercury, the latest mission that you should know is your Bepi Colombo. Bepi Colombo. Bepi Colombo is a mission of ESA. BP Colombo is a mission of ESA, and it has been launched in 2018. It will reach in 2025. So by this time, it will be a flyby mission until it reaches. But when it reaches, it will become an orbiter type of mission. So this is the most important mission that you should know. One of the earlier mission was also Mariner 10, but this is not very important. Mariner 10 is an old mission. This one is an old mission. This is an old mission. This is a new mission. So this mission you should remember with respect to Mercury. With respect to Venus. So Pioneer was an old mission that is not very important, but the latest missions that you should be knowing is your Da Vinci. Da Vinci will be a mission of NASA. Then we have a Veritas mission, which will be sent by NASA only, and then we have this Envision mission. So this mission is of ESA. So this is of ESA, that is European Space Agency. This is of NASA. So here what we'll be doing is that this one will be an orbiter type, and here we'll also send a probe down to the surface of Venus. So these are future missions. Da Vinci, Veritas, Envision. These are your future mission, and they will be sent in late 2020s. So in late 2020, later in this decade, these missions will be sent. So you should remember these missions. So UPSC can ask questions based on this. And India is also planning this Sukhrayan mission. So it is expected to be launched by December 2024, but it has been delayed. So It will study the atmosphere of Venus. So Pioneer is an old mission, but you need to remember the newer mission, that is Da Vinci, Veritas. One unique thing about these missions are that they have this alphabet V in them, so you can clearly identify that these missions have been sent to Venus. Now let us look at these moon missions. So we are now looking at mission to Earth's moon. So these future missions are important for us to know. So in this we'll also see this Artemis mission, and in this this change 4 mission of China, this was also significant. That is an old mission. So we have sent Chandrayaan 1 and 2. Bereshit is of Israel. Bloody Grail, these are older missions. Artemis, these are older missions. These are not very important. Bereshit is of Israel, and it also tried to do soft landing, but it failed. India Chandrayaan 2 also we would try to go for soft landing, so we had gone for Vikram lander. So Vikram lander crash landed, so that is why it was in news. So we'll see. So this change mission, why the change mission of China is very important, because it landed on far side of moon. It landed on far side of moon. So far side of moon is the side which we do not, or which we cannot see, or which we do not see from Earth. So why we cannot see the other side of the moon? Why we cannot see the other side of moon? Yes, anybody would like to try why we cannot see the other side of moon? This made history. This change mission made history by sending it to the far side of moon. Okay, so these are your future missions. So Peregrine mission, Luna is of Russia. Then these Omotenaci Equus Slim, this is of Japan. So their space agency is called as JAXA, and Korea's Curry Prime and Lander. So these will also be sent. So the most important mission among this moon mission is your Artemis mission. So Artemis mission, it is said that from Artemis 1 to Artemis 8 will be sending these missions. So what is the significance of this Artemis mission? That it will be manned mission. It will be manned mission. We have already sent the Artemis 1 mission, and we are planning to send Artemis 2, and then we'll send Artemis 3. So Artemis 3 by 2025 we'll be sending. Artemis 2 will be sending by 2024. So it will be a crewed mission. It will be crewed, it means it will be manned, but no landing will be done here. Landing will also be done on moon. So in this mission, so the objective of the Artemis mission is to make moon, the surface of moon and its orbit, as base, so that we can go for further space travel. So the moon's surface will be used as a base for future or further space travel. That is the idea of the Artemis mission. So it is going beyond the Apollo mission. So Apollo mission was the earlier manned mission. So even in Apollo 11 was the first manned mission. Apollo mission had started in 1968, but the Apollo 11 mission was sent in 1969, and in this mission only Neil Armstrong and Buzz Aldrin, they landed on surface of moon, and Francis Collin also went with them, but Francis Collin remained in the orbiter, while Neil Armstrong and Buzz Aldrin, they landed on surface of moon, and then they again launched back. They rejoined with Francis Collins, and sorry, not Francis Collins, Michael Collins. So rejoined with Michael Collins, and then they came back to Earth. So the Apollo 11 mission continued till 1972. So it continued till 1972. So till 1972, 12 astronauts have walked on surface of moon, and after that there were no manned mission to moon, and then we have started again this Artemis mission. So in Artemis mission will be going again for moon landing. So it is expected that by 2025 we'll see once again moon landing. So that is the significance of this Artemis mission. India, the Indian mission to moon, the Indian missions to moon. The first Indian mission was your Chandrayaan 1. So it is an orbiter. It was an orbiter type of mission, and the most significant finding of this Chandrayaan 1 was that we found water on the surface of moon. So this is a significant finding of Chandrayaan 1. Chandrayaan 2, you would have remembered that in 2019, when we sent this mission, the the lander that was the Vikram lander, it crash landed. The Vikram lander crash landed, and the Pragyan, that was the rover, that was also lost. So it had crash landed. So we are trying to do what, soft landing. So this concept of soft landing is very critical. So not many countries have been able to do soft landing on moon. So in the Chandrayaan 3 mission, it will be a repeat of the Chandrayaan 2 mission, but we'll be again attempting soft landing on the surface of planet and Mars was done by using parachutes to reduce the speed of the time. So this is with respect to other planets, but on moon not many countries have been able to do soft landing. So only 3 countries have been able to do soft landing on moon. So one is obviously your USA. Then your homework is to find which are the other 2 countries. Let us just look at the Gaganyaan mission also. So in the Gaganyaan mission, it will be a manned mission only. So we'll be sending 3 flights in this. 3 flights will be sent in this. So we'll have what is called as the orbital module, in which we'll have 3 Indian astronauts, including a woman. So in the first flight will be a trial flight. Second flight will be sending a robot. A robot in the second flight is named as Vyomitra. Vyomitra will be sending Vyomitra, and in the and then the third flight will be actually sending the astronauts. So in among the 3 astronauts, one astronaut will be a woman, and we previously said that it will be sent to what? It will be sent to low Earth orbit at an altitude of around 300 to 400 kilometer, and they will remain there for 5 to 7 days. So this is the Gaganyaan mission. So it will have your crew module and the service module. Crew module, it will be carrying the human beings, and the service module, it will be powered by 2 liquid propellant engines. So this will send the astronauts to space, and it will be equipped with emergency escape and emergency mission abort. So these are critical components which are needed for safety of the astronauts. So we have escape mechanism, we have abort mission, and we'll be using GSLV Mark 3. So this is the most powerful launch vehicle that we have till now, and the expected cost is around rupees 10,000 crore. So these are some of the unique features of the Gaganyaan mission that you should be knowing. So with respect to Mars, so in 2021, 3 missions reached to Mars. So one was Perseverance. Second was Hope of UAE, and third was Tianwen of China. Tianwen 1 of China. So so Mars is said to be the most explored planet. So previous missions was your Perseverance, and in Perseverance also we have sent one helicopter which is known as Ingenuity helicopter. So this helicopter made a history when it made a powered flight on any other planet. So it made a history because no other aircraft has flown on any other planet, but it flew on Mars. So that is the uniqueness about this Ingenuity. And then the earlier missions were your this Hubble, Insight, Mars, Odyssey, Pathfinder. These are old missions, not very important from exam point of view, but this one is important. So we'll try to develop some understanding of this one, Mangalyaan mission. So this Perseverance mission Perseverance mission was launched in 2020 and it reached in 2021. So it takes around a year. It takes not around a year. It takes around 6 months to reach Mars. Okay, so this is the Perseverance. So here you can see that it has a drill. So it has a drill which collects samples from the surface of Mars. And there was the earlier mission, which was the Curiosity mission, which was also sent to Mars only. So it is another rover. So as of now, we have seen that there are two rovers. So one rover is also of China, that we'll see. And this is the Indian mission. So the Indian mission, Mars mission. So Mars mission of India was sent in 2014. So Mars mission of India was sent in 2014. It is India's first interplanetary mission, and India became the fourth space agency to reach Mars. After US, NASA and European Space Agency is the first Asian nation to reach Mars and the first nation in the world to do so in the first attempt. So this is the uniqueness about our Mars mission. So we were able to send it at a very low cost, and we were able to send it in first attempt, and we were the first Asian nation also. By this point of time, China was not heavily investing in sending missions to Mars, but by this point of time India was in the lead. But later on, if you will see that China has taken the lead. Next is the MOM2, that is the Mangalyaan mission. So in Mangalyaan mission it is a second interplanetary mission planned to launch to Mars. So we had planned to launch in 2021 22 time, but because of COVID it has been delayed. And because it has been delayed, so it was supposed to be a lander and rover type of mission, but it has been delayed. And by this time China has taken lead. So China has sent the Tianwen 1 mission. So China has sent the Tianwen 1 mission. Let us just try to do this question. Yes. Consider the following statements. The Mangalyaan launched by ISRO. It is called the Mars Orbiter mission. In made India the second country to have a spacecraft orbit the Mars after USA. Made India the only country to be successful in making its spacecraft orbit the Mars in its very first attempt. Yes. Yes, anybody? So it is, yes, it is called as the Mars Orbiter mission. It made India the second country. No, this is not a correct statement. It made no it India was the fourth country. India was the fourth country to reach Mars. So after USA, so you have Russia, you have ESA. So they have reached before us. They have reached before us. So second statement is wrong. So if second statement is wrong, so your C and D option is wrong. Made India the only country to be successful in making a spacecraft orbit the Mars in its very first attempt. So yes, this statement is correct. So this statement is correct. So the correct answer in this scenario, in this case, is your C. Now let us see some of the missions to asteroids. So we have seen missions to Sun, we have seen missions to Mercury, Venus, and Earth's moon. Let us now look at missions to asteroid. So mission Lucy, and then we'll see this mission, Dart mission. So these are the important missions, and these older missions are not very important, but you can just remember Osiris Rex, Dawn, near Hayabusa. Hayabusa was sent to asteroid Rygu, and Procyon, it is a flyby mission. Dawn was sent to Ceres and Vesta, not very important. Let us just look at, so this is the asteroid belt. So this is the asteroid belt. So we have seen mission to Sun, we have seen mission to Mercury, we have seen mission to Venus, we have seen mission to Earth's moon. So we have seen mission to Earth's moon, we have seen mission to Mars. Now we are looking at some of the important missions to asteroid belt. So mission Lucy. So mission Lucy has been sent to the Trojan asteroid. Trojan asteroid. Trojan asteroid. What is a Trojan asteroid? So here you can see that most of the asteroids. So this is Mercury, this is Venus, this is Earth, this is Mars. So this is the asteroid belt. This is the asteroid belt that you are seeing. But in this Jupiter's orbit, so this is Jupiter, and here you are seeing that ahead of Jupiter and behind Jupiter, so there are some asteroids. These asteroids are called as your Trojan asteroids. These asteroids are called as Trojan asteroids. So we have sent this mission Lucy to the Trojan asteroids of Jupiter. So the why are we so much interested in Trojan asteroids? So why have we kept the name Lucy? So Lucy was an ancient human ancestor. So if you would have read in anthropology, so Lucy is the ancient human ancestor from which we have evolved. So Lucy, the study of Lucy revealed that how humans have evolved. So we get an idea about the evolution of living organisms because of Lucy only. And similarly, we believe that asteroids, they are the leftovers from formation of solar system. So if we can understand the asteroid, if we study the asteroid, then we can understand the origin of our solar system itself. So your planets, your moons, they have changed over the millennia, but the asteroids, they haven't changed over millennia. So that is why we are interested in studying about asteroids. So this mission Lucy was sent to the Trojan asteroid of Jupiter. Now let us look at this DART mission. Now with respect to asteroids, there is a existential fear also with respect to asteroids. So we know that asteroids previously have hit Earth. So dinosaurs died 65 million years ago because asteroids hit Earth, they destroyed Earth, and after the dinosaurs died, mammals emerged. And very recently, two decades back, some of the asteroids have hit some parts of Russia. So asteroids keep hitting Earth, and in future it is expected that some asteroid might hit Earth again. So what are we trying to do here is that we are trying to develop some Earth protection mechanism so that if an incoming asteroid is there, so we are able to deflect it or we are able to destroy it. So we are trying to develop some mechanism to deflect these asteroid. So in this mission, so it was an experiment. So in this experiment, what was done, so we took two asteroids. So there is one large asteroid here, so this is the large asteroid here, that is Didymos A, and there is a small asteroid here, Didymos B. This small asteroid is making a revolution. It is revolving around the orbit. It is revolving around the orbit around this larger of the asteroid because of gravity. And what we have done, we have taken a spacecraft and we have flown this spacecraft into this smaller of the asteroid. It has made an impact, it has collided with the smaller of the asteroid, and because of that it has changed its orbit, or its orbit has seen some deviation. So we have been able to deflect it. So this was the experiment. So this is the DART mission. So what is the full form of the DART mission? So double asteroid redirection test. So I guess the full form is not given. So double asteroid redirection test. So we were able to deflect this asteroid. Double asteroid redirection test. So we have moved this asteroid at a relative high speed compared to this asteroid, and after the collision we were able to deflect it. That is the idea of this DART mission. So there are other such mechanisms that we are trying to develop. So NASA along with ESA, they have formed a HERA mission. So in that HERA mission they are trying to develop, or they are trying to collaborate and develop some other mechanisms to deflect or destroy the asteroids which can come in future. So now let us look at missions to Jupiter. So in Jupiter, so this is the most important mission that you should know, Juno mission. But you should also find out what is this JUICE mission. So this is the latest mission with respect to Jupiter. So JUICE mission is of ESA. It is a planned mission, so it will be an orbiter type of mission. So Juno mission was sent to Jupiter. Europa mission again. So this Europa mission is not to Jupiter but it's moon. So Europa is one of the moon of Jupiter. So Jupiter itself is not habitable. So we know that, or we believe that some of its moons might be habitable. So there are Jupiter has some of the largest moons, or it has the most number of moons in the entire solar system. So the four most important moons of Jupiter are Io, Europa, Ganymede, and Callisto. So we are sending one of the mission to Europa mission. Galileo and these missions are old missions. These are old missions. Voyager again. So Voyager 1 and Voyager 2, they were with respect to Jupiter, they are a flyby mission. With respect to Jupiter, they are a flyby mission. This Voyager 1 was to Jupiter and Saturn, and then this Voyager 2 was to outer planet. They both have moved outside of what is known as heliopause. Outside of heliopause. So this is the Juno mission. Juno mission has approved an update to Juno's mission. It will continue, and it has been continuing. So with respect to Jupiter, you should this is just an image to show. With respect to Saturn, so there is this Cassini-Huygens missions. So Cassini-Huygens mission, so it was sent in 1997, and it completed its mission in 2017. So it was brought down to the surface of Saturn. So this mission is also over now. So with respect to Uranus and Neptune, not many missions are there, but we have this Hubble and the Voyager mission. So Voyager missions, they look like this. So the at present the Voyager mission is beyond this heliosphere. What is this heliosphere? It is the boundary of the sun's magnetic influence. So heliosphere, the sun sends charged particles. So these charged particles, they form a bubble like structure. So this is the bubble that you are seeing. So this is your heliosphere. So we are inside heliosphere, but a sun's gravitational field exists even beyond the heliosphere. So this heliosphere is the boundary of the sun's magnetic field. So there is a space beyond the heliosphere also, which is called as the Oort cloud, where sun's gravitational influence is ending. So that is the end of your gravitational influence of sun. That is actually the end of the solar system. So New Horizon mission has been sent to the Kuiper belt. So it has been sent to Kuiper belt, and it has studied Pluto, and it has helped in finding the moons of Pluto, that is Corberus and Styx, and has also observed this Ultima Thule, the most distant target in history. So Ultima Thule, it looks the Thule. The Ultima Thule is this only. It is a space rock, so it looks like a snowman. So this larger lobe is called as ultima, and this one is called as thule. So it is the most distant object that we know with respect to Earth. So recently it has been renamed as Erokoth. So this ultima thule has been renamed as Erokoth. Okay, so let us just try to see this Hubble telescope. Hubble telescope is a space-based telescope. So you can see that it has a design very like a very conventional telescope. Only the only idea here is that it is a space-based. So it has made many observations. So it has made many significant observations. But we have not replaced, but Hubble is still in operation. But we have also sent another space telescope, which is called as the James Webb telescope. So here in the James Webb telescope, you can see it looks very different from the Hubble telescope. Here you can see it has a concave mirror, and the lights will fall on this mirror, and then they will be reflected on this part, on the focus part, and then we'll make the studies. So here you can see it has very exhaustive heat shield mechanism. So there are 5 layered heat shield mechanism. So all of this can work only if it is at lower temperature. So this mechanism works well when it is at lower temperatures. So we'll just try to compare and see Hubble telescope and James Webb telescope. So James Webb telescope observes in the infrared range. Because it observes in the infrared range, it can see farther. It can see farther than your Hubble telescope. Your Hubble telescope observes only in ultraviolet and visible part, so it cannot see very far away objects. And the diameter of the mirror is also small. So we have small mirrors here. Here we have very large mirrors. So here we are deploying very large mirror, and James Webb telescope has been sent to L2. The advantage of being at L2 is that it can look deeper into space. So its location is also advantageous. It is already present quite deep into space, and then it can look further into deeper into space. That is the advantage of your James Webb telescope. So let us just try to see other parts of space technology. So let us just try to understand these concepts of black holes that keep coming in the news. So in order to understand these gravitational waves, we need to understand the concept of what is known as space-time. So what Einstein is saying, Einstein is saying that space and time are interrelated. So he believes that space space and time are interrelated. Space and time are interrelated. So how can we imagine space and time? So he says that your space time is nothing but like a piece of cloth, and what it does, what matter does, so it is like a ball. If you place a ball on this cloth, the cloth gets warped. So in this diagram you can see that the space time matrix is getting warped. So because of this warping of the space-time complex, you see that if you, let us say, if you take a small metal ball here, and if you leave it, then you'll see that it will fall, or it will move towards this larger ball. So and Newton said that there is force of attraction between this object and this object, but Einstein says that the object are coming closer towards each other, not because of force of attraction, but because of the shape of the cloth itself, or because of the shape of the space-time matrix itself. So what is matter doing? Matter is molding or bending the space-time matrix itself. So if you take this as sun, so it is warping the space-time. If you take a black hole, it will warp the space-time matrix more. So because of that, so there are variations. Because of that, we are saying that it leads to different phenomena. So Einstein gave two theories. One theory was of a special theory of relativity, and the other theory was known as general theory of relativity. Let us just see some aspects of special theory of relativity. In the special theory of relativity, he said that space and time are interlinked, and he said also said that light is the fastest, or nothing can travel faster than the speed of light. So this is the fundamental limitation. In the special theory of relativity, he also said about E is equal to mc square. That is not very important from exam point of view, but the most important aspect of special theory of relativity, which he gave in 1905, was that matter, that the space and time are interlinked. Then in general theory of relativity, which he gave in about 10 years time later in 1916, so he said that matter is warping space-time. So the diagram that you have seen previously, he is saying that matter is warping space-time. So that is the idea of space-time getting warped by matter. And he also says in his general theory of relativity, he gives the idea of black holes, he gives the idea of singularity, he gives the idea of wormhole. So what are these black holes? So black holes are nothing but they are what matter which has so huge gravity that it bends even lights, it doesn't allow even light to escape. So if you look at this diagram, if you have a black hole placed here instead of this ball, so it would have warped the space-time matrix to a very large extent. So that is the idea of the black hole. According to him, it is bending more light it is bending the more space-time. So in this diagram, what you can see, what is singularity then? So a singularity, so scientists were trying to give an answer to the question that what happened before Big Bang, what was there before Big Bang. So many scientists and especially Einstein said that before Big Bang there was something called as singularity. What is singularity? Singularity is the, for you simply understand, singularity is the center of the black hole. It is the center of the black hole. This center of the black hole kind of exploded and led to Big Bang, and the whole universe has come into existence. So this is just showing the black hole. So what is this wormhole? So wormhole, the idea of wormhole is that your space-time matrix is curved in such a way. So in this diagram you can see that the space-time matrix, this is space-time matrix, this hole is curved, this everything is curved in such a way that there are some bridges that are formed. So can you see the bridges here? So these there are some bridges. So if we travel through these bridges, then we can do short travel, or we can do essentially what is known as time travel. So all these concepts are related to your space-time matrix only. So there is bend or curvature in the space-time matrix. So because of that, some bridges are created, and these bridges are called as wormholes, or these are also called as Einstein-Rosen bridges. So Nathan Rosen had also contributed. So these are known as your Einstein-Rosen bridges. So what are gravitational waves? So gravitational waves are ripple in space-time matrix. Gravitational waves are ripples in space-time matrix caused by some of the most violent and energetic processes in the universe. So energetic processes in the universe, it could be like merger of two black holes or merger of two neutron stars. However, this prediction was given by Einstein itself, by Einstein himself way back in 1916, but it was experimentally proven for the first time in 2015. So you would remember that in 2015, so this LIGO detector detected the gravitational waves, and they even received the Nobel Prize also. So gravitational waves is very important. So gravitational waves, so LIGO is what a gravitational wave interferometer. So LIGO. So this is LIGO. So in LIGO, the two arms are created. Two arms having length of 4 kilometer. They are created. So two arms are created. So you send a laser light. You send a laser light in the two arms. So one laser light moves in this direction, another laser light moves in this direction. Because the length of the two arms are same, so laser then reflects back from the end and reach at this point only. Because the two arms are of the same length, the laser would take the same time to reach this point. But if a gravitational wave hits this apparatus or this system, then one of the arms gets compressed and the other arm gets elongated. Because of that, now there is a difference in time recorded, and that is how, so it is recorded. So that is how the LIGO detects the gravitational waves. So this is your earth based LIGO detector. So in USA you have two LIGO detectors, then you have it in one in Italy, and then you have in Japan, and recently in India also we have announced that we'll be setting one LIGO detector. So LIGO, what is the full form of LIGO? It is a gravitational wave interferometer. Interferometer interferometer So let us just try to solve these questions. What is the purpose of the evolved laser interferometer space antenna? Yes, anybody? Okay, so whenever you see this term interferometer, it means that it is being used for gravitational wave observatory. So here, so we have LIGO. LIGO is earth based. So LIGO is earth based. Then you have LISA. LISA is a space based antenna. So LISA is at L1 point, and we are going for evolved LISA. So evolved LISA will be a space. It will be a combination of three spacecrafts. So it is a future mission where we'll be sending three spacecrafts, and they'll form a triangular pattern, and they will detect the gravitational waves only. So that is the idea of this LISA. So LISA Pathfinder European space mission that successfully tested the technology necessary for the laser interferometer space antenna. LISA Pathfinder was launched in December 2014. LISA Pathfinder is placed at Lagrange point, which is about 15 lakh kilometer from Earth towards the Sun. The mission ended in 2017. LISA Pathfinder is paving the way for future missions by testing in flight the very concept of gravitational wave detection. So next is your evolved LISA. The evolved LISA mission is a mission aiming at exploring the gravitational universe from space for the first time. The ELISA mission consists of mother and two daughter spacecraft, so they will form a triangular configuration. The three satellites will form a precision interferometer with two daughter spacecraft connected to the mother 1 by 1 million kilometer long. So that is the idea here. So in this sense, ELISA will complement the efforts of the ground-based gravitational wave observatories or ground wave detectors. So that is the idea of ELISA. So this is one of the pictorial diagram to show you LISA. So here, so this is our sun. This is our sun. This is our Earth. And here you can see there are three spacecrafts. So we have one spacecraft, second spacecraft, and here we'll have third spacecraft. So this, in this diagram, what you can see, that let us say two black holes have merged. When they have merged, so they are creating ripples. So these waves that you're seeing, these are ripples in space time matrix, and these ripples will hit the system, so it will detect these. So in LIGO also we go for laser interferometer only, so here also we are using the concept of laser only. So this is the evolved laser. Okay, so if there is any doubt, let us take some doubts. Okay, let me just bring the first questions. Yes, let us just try to solve this question. Recently, scientists observed the merger of giant black holes billions of light years away from the Earth. What is the significance of this observation? Yes, anybody would like to try? Okay, so let us look at this question. Recently, scientists observed the merger of the giant black holes billions of light years away from the Earth. What is the significance of this observation? So, Higgs boson particles were detected, gravitational waves were detected, possibility of intergalactic space travel through wormhole was confirmed. It enabled the scientists to understand singularity. So, here it is when black holes merge, they create ripples in space-time matrix, and these ripples can reach Earth also, and we can detect them. So these are related to gravitational waves. So the correct answer in this case is your B. Let us just look at this question also. The term event horizon, singularity, string theory, and standard models are sometimes seen in the news in the context of. Okay, so these are in context of observation and understanding of the universe. So event horizon, so it is related with your black holes. Singularity, it is related with black holes. String theory and standard model, this is related with atomic and subatomic particles. So they both, all these theories are helping to understand the universe better. So with this we'll try to end this session. So if there is any doubt, you can ask. So in the next session, we'll try to cover some of the smaller topics related to defense technology, related to nuclear technology. Nuclear technology also will try to cover, and we'll try to cover nanotechnology. So we'll try to cover these topics in the next video. So is there any doubt? So if there are no doubts, we'll close this session.